A warm welcome to everyone. My name is Oliver Mandal, and I'm Senior Product Manager for Process Probes and Flow Cells at Hellma. I'm delighted to host today's webinar featuring our expert speakers, Roberto Beghi, Valentina, Giovenzana, and Alessio Tugnolo. Together, we'll explore the topic, Smarter Quality Control with NIR, real-time insights from the agri-food sector. Today's experts represent a research group operating within the Department of Agricultural and Environmental Science at the University of Milan. Their work focuses on green, non-invasive optical sensing technologies, especially with and NIR-Spektroskopie and imaging, to develop cost-effective, field-ready devices for real-time quality assessment in the agri-food sector. They also apply advanced chemometric modeling and conduct life cycle assessment studies to evaluate environmental sustainability. The team has made notable contributions to European research initiatives, including the Horizon 2020 iGrape project, which integrated IoT and optical sensing technologies for smart vineyard management. Together, the research group advances innovative, data-driven solutions that foster a more efficient and sustainable future for the agri-food sector. I'm glad they found the time to share their experiences with us today. Welcome, Roberto, Valentina, and Alessio.
Thank you, Oliver. Now, today, we will start with a short introduction to our department and our research group, and then we will move into the PAT application we are working on or already concluded. About our department is the Department of Agriculture and Environmental Sciences, belongs to the Faculty of Agriculture and Food Sciences in the University of Milan. And the mission of the department is to provide sustainable solutions for agri-food systems. And how do we do this? Firstly, we use scientific innovation to support the company, not only the big company, but in particular small and medium enterprises, applying our know-how to promote sustainable practices. And secondly, we also share skills on good practices to empower students and to prepare them for the job market. As you can see, we have a strong team of professors, researchers, and PhD students working on national and international projects. And currently, we have a project that are worth 17 million euros. We are structured in 5 disciplinary sections that ensure a multidisciplinary approach across the agri-food and environmental domains. Here you can find the full information description of our research areas and expertise on our website, as well as the degree programs connected to this topic. The same staff in the University of Milan are responsible for both research and educational activities, ensuring the strong link between the innovation, the research innovations and educational. Going in deep, going into more detail about our team, in addition to Roberto, Alessio, and myself, our team includes also Riccardo Guidetti, full professor, Abhishek Narote, research fellow, and Arianna Kuzmai, PhD student. we work all together about two main research directions. We combine optical sensing innovation with sustainability. So in addition to PAT applications, on one side we design, developed and test cost-effective solution to make real-time quality monitoring to support small and medium enterprises. And on the other side, we are able to quantify the environmental and economic and social impacts of production in agri-food systems through the ISO-based life cycle assessment method. That's it for my side. So now I'll leave the floor to my colleagues. They will present our case studies one by one. Please, Roberto.
Thank you, Valentina. Going to the details of the topic of today, we show you now some field of application in collaboration with Hellma Solution. So we move now to the grape and wine sector and the project related to this field. Then the last part of the presentation, we will show some application regarding classical PAT application on coffee and the bakery sector. Moving to the grape and wine is one field that is a very crucial one for our research group. We have current different projects from the field, also in the post-harvest phase, and moving also in the winery, inside the winery for the fermentation monitoring. So starting from the field, from grape maturation and water stress monitoring, we have different kind of project and approaches. We will show what is our approach of proximal sensing related to the handheld sensor and the development of standalone sensor directly installed in the field. Starting from the water stress monitoring, we have performed several projects testing directly in field acquisition with equipments from Zeiss and from other producers, for instance, the Aurora NIR that is from Zeiss, and the Quality Spec Track that is another handheld devices. In this case, we want to apply the spectroscopic approach to estimate a physical aspect that is the water stress, that is a very complex feature to be monitored, because we have for reference devices like the Scholander pressure chamber that is quite time expensive and not so easy to perform. So moving to easy and fast devices like NIR-Spektroskopie for this approach is quite desirable. So in this case, we start with the acquisition during the night because we need to have a correct balance with the field and the vineyard. We can see also the modeling phase in this slide. We have no time to go into details, but we developed modeling and we studied the evolution of the spectra during the different phases of the stress. And we then go to a prototyping phase. Imagine a device with a selected small number of wavelengths. In this case, you can see our prototype with the sensor and the wavelength that we consider, so a wavelength in the visible range, 2 wavelengths in the visible range, and the wavelengths around the water peak of absorption in the NIR region. It was installed directly on the field, as you can see in this picture. This kind of application is a parallel one by the grape maturation monitoring, so the same approaches but with a different object. In this case, we need to precisely define the correct moment for the maturation to go to harvest the grape, because a correct harvesting timing is strictly related to the value of the grape. So this is the object. And also in this case, we develop prototype in different projects. First of all, we show you a prototype that we already patent, and is an one, very, very simple, based on several wavelengths, more in the visible and a couple of wavelengths in the near-infrared region. We perform also in this case modeling, and so we have estimated parameters, the classical parameters like the total sorbose content related to the sugar content, the pH, and so on, and the acidity. Results you can see moving to the R square are quite good for this kind of this device that is also a prototype. We show you also this in this video also another prototyping that is more complex. It's related to a network of sensor that is funded by the Horizon 2020 program. The project was the iGrape project, and you can see how this small device, a small sensor installed directly in the bunches will run lightning also in a couple of wavelengths to the single berry, and we can in a direct way have during the season, the ripening season, constant monitoring of the evolution of the monitoring. So you can see it's quite easy, quite simple to perform. Of course, it was a project with different partners and also IoT partners for the developing of the sensor network. Moving on, this is results from this project. We have this sensor network with 18 sensors in different rows. So this amount of data were elaborated and used to perform outcomes. So the maturation curve, you can see the one based on the classical points of sampling performed by the testing vineyard, and the one that is the curve, the blue curve, that is one achieved by the sensor network. So you can see we have a good result. We are very satisfied of these outputs of this project. Then moving on, we go in post-harvest. So during the phase of entering the grape in the winery, so the selection phase of the grape. In this case, we have problems related to the selection, mainly related to the quality and the disease inspection of the grapes. In this case, we move also for the grape quality monitoring, but in particular to test our devices on the phytosanitary status monitoring. And in this case, you can see two different approaches. One directly on the bunches, using, in this case, the corona process analyzer from Zeiss. So you can see the wave range, so visible plus the near infrared, and then in a different configuration directly on the mast, so on liquid samples using again a Zeiss spectrophotometer, and then the probe from Hellma for the reflection measurement and the transmission measurement. So different setup we have tested. Moving fast to the results of this experimentation, considering the acquisition directly on the bunches, we approached a classification modeling using the PL-SDA algorithm. So we are talking about chemometrics, choosing a cutoff values and separating the healthy bunches from the infected bunches. So in this case, we have the classical parameter for classification, meaning the accuracy of correct classification. And you can see we have also calibration phase map, but also the cross-validation one that is quite good. And finally, the one from directly from the collection on the mast, the same approach from data analysis. Also in this case, accuracy very good. Also in this case, from different types of grapes, better for the white, for the red, but overall good results. This is an overview of our experience on the grape and wine sector. Now I give the floor to Alessio for the last part, starting from coffee.
So thank you, Roberto and Valentina. So let's move toward a more industrial production, and I will speak about, in this case, the experience that we had in the coffee production. We collaborated with a very well-known company here in Italy, and of course with Hellma solution. And in this project, the company, the problems related to the company was related to the quantification of moisture content after the roasting phase. So they used to use specific devices that is moisture analyzer, so basically is a thermobalance. And the idea is to have something that can be installed directly in the production chain for online or inline monitoring, or something that can be used by an operator. So they were starting to see how they can monitor the amount of moisture inside these products. And the idea was to, okay, let's see these devices, how can perform this evaluation, and if it's better or not compared to the performance of the moisture analyzer. This is the goal of this project. So we will know that with NIR-Spektroskopie, we can see the water, we can quantify the water, so this chemical compound can be easily detected by this instrumentation. So we decided to use it and comparing the results with the thermogravimetric moisture analyzer. The models were built with using as a reference the ISO method in the oven, and after we built the model, we compared the performance of the NIR models respect to the performance of the estimation of the moisture content with the thermogravimetric moisture analyzer. That I will remind you that takes from 3 to 5 minutes to estimate the amount of water inside this product. So we perform a statistical comparison using a passing bubble regression. So basically, it's a significant behavioral test where the null hypothesis is verified when the slope is not significantly different from 1, and in the same time, the intercept is not significantly different from 0. That means that there's no significant difference between the devices at 95% of significance. So we obtain pretty good result for both of the instruments, of course, because are the devices that are used for this goal. So the null hypothesis was accepted for both of them, but we want to know which one is the best one. So we're using this index based on the residual sum of square. We estimate that this RDI, so residual dispersion index based on the error, that 5.93% was obtained of error was obtained for the NIR models, and 99.68% was obtained for the moisture analyzer, meaning that the NIR devices was a bit more better than for the estimation of the moisture content. And so the company was quite interested on the use of the device, and 4 NIR devices were bought for this application. Moving on another food chain, I'm speaking about baking. Also here we are currently working with them. It's a big company in Italy for the production of baked products, and in particular we are working on biscuits. And during this project, one of the most important parameters is always the moisture. Moisture is, during the food production, food transformation is a very important aspect. But the hot topic in this process was the estimation of the acrylamide content. Acrylamide is a potential cancerogenic compound that for the European regulation, the limits of acrylamide content is fixed at 350 micrograms per kilo. So, and since it's cancerogenic, and if we think that this product can be consumed by also, and especially by children, this is a quite important topic to estimate the amount content of acrylamides. For this aspect, we tried different devices. One of them is the Corona process, the ones that we already showed you. And this device is the only one that combines the visible range and the NRR range, and is well designed for online or inline application, so pretty good for PAT application. And then we tried also other devices. This SpectraStar is the by Unity and works mainly in NIR, is more at-line devices, and FT NIR spectrophotometer by Bruker, and also here is a mainly NIR device. This approach, this project has been performed also in collaboration with another department here in UNIMI, and here just to show you the both results concerning moisture, the moisture content, sorry, and as we well know that the moisture can be detected pretty well. And just to show you the raw data here on the left, where the spectra are labeled according to the amount of moisture content, we can see that the color bar that is highlighting the color trend, we can see where we can detect the variance related to the concentration of the moisture. That is suggesting to us that the water can be detected pretty well also on these products. On the right, we can see the first models that we tried, and with tested with an external test set, and obtaining 0.3% of error on the estimation of the water. So pretty interesting results for the water estimation. Moving to the top topic, and so the acrylamide. We just to give you a fast overview. The acrylamide was better estimated with our Corona process device. The models that we obtained were quite robust at this stage with an external validation. And however, we need to go more in detail on to evaluate the robustness of the models. So it's something that is still ongoing, trying also these models that we develop with similar biscuits that are produced in the same plant. So just to give you other projects that are still ongoing, so at the very beginning, we are working on this Colibri project that the idea is to work using miniaturized drones. Miniaturized, I mean drones with weight less than 250 grams. And these drones can be combined with thermal or hyperspectral cameras. And the idea is to use it inside the vineyard. So the drones can fly along the rows of the vineyard, perform an object detection, and evaluate the quality aspects of the grapes and the healthy status of the plant. And another project that is still ongoing is more in the binary. So we are collaborating with a company that is producing this nutrition machine to feed the must during the fermentation, so feeding the yeast during the fermentation. One particular thing of this machine that is able to control, to monitor the fermentation with different tanks. So it has several probes that are connected to different fermentation tanks and can feed the yeast. An important asset that we can the company needs to have is the feedback on the amount of sugar that is consumed by the yeast. So that's why we are introducing this miniaturized spectrophotometer inside the probe and coupled with the specific light sources in order to have a detection of the amount of sugar, so developing models for detection of sugars that remain into the grape must, and giving active feedback to the machine that is able to provide the perfect amount of nutrition, the perfect nutrition to the yeast. So I guess my time is up. I will leave you a couple of links if you are interested in what we are doing, and I will say thanks for this time.
Thank you very much for your very interesting presentation. I think it was very insightful and also very interesting for me to see the good spread of applications from lab to field to process. And if you would like to share your PAT experience and take the stage as a future speaker in our PAT webinar, we would love to hear from you. So please feel free to get in touch with us. Thank you once more to our speakers and also to our audience to join our webinar. Thank you for your participation. Keep an eye on our website for the upcoming webinar dates. The next PAT-Forum webinar will likely take place in April after Easter holidays. Have a great day and goodbye for now.
Bye-bye. Thank you.